Hello, everyone. My name is Joao Goncalves. I'm one of the solutions architect here at Version 1, and welcome to this webinar about modernizing applications with Microsoft Azure technologies. So depending on time, we'll try to ask some questions at the end, so please leave them in the question section. So why is Version 1 well placed to talk about application modernization? As you can see, Version 1 has a large number of competencies in the Microsoft space, ranging from cloud platform, data analytics, DevOps, and application development and integration. And last year, we were recognized with the Microsoft Intelligent Cloud Award, and we were nominated as one of the Global Data Estate Modernization Partners of the Year, as well as the first in the UK and Europe to be specialized in modernization of web applications to Microsoft Azure. Justin, I'm gonna leave it down to you now. So just from Microsoft.
Thank you, Joao. Hi there, my name is Justin Davis. I'm the business group lead for application innovation within Microsoft. So I work very closely with the likes of Version 1 and our customers in terms of taking them on the journey with regards to modernizing their applications and developing applications in a cloud native way. When we start talking to customers and really figuring out where their pain points are, talking to CIOs and CTOs, 91% of them said that they see digital transformation as a way of kickstarting innovation. And 85% of them, which is quite a scary number, say that if they don't offer digital services or become cloud native or adopt cloud and innovative working, then actually they think that they will just become totally irrelevant. And for Microsoft, whilst we are one of the largest cloud providers, for us, really, it's about figuring out how do we start that customer on that journey. When we start thinking about, on-premise infrastructure, and when we think about applications which you have to install into servers and rack and stack them and install the operating system and patch them, really, you're bound by the amount of time it takes to be able to actually do that. And when you start thinking about innovating and when you start thinking about reacting to customer demands, as quickly as possible for the sake of your business, you don't need to be bound, or you shouldn't be bound by those kind of aspects of having to procure the infrastructure and have your operations team spin those up. So when we start talking about application modernization, whether it's the ability of closing down a data center and shifting that infrastructure over to Azure, really the next step after that is then thinking about, well, how do we make that more efficient? How do we take those applications and move them over to a platform as a service so my ops team doesn't have to deal with the day-to-day running of those, and it frees up the resources I have to be able to actually start innovating. And so we see application modernization as kind of the kickstarter or the catalyst to be able to start that journey and innovate and respond to your customer demands quicker than you have been, quicker than your competitors can be, and really frees you up to be able to start going on that innovation journey and thinking about what you can do to be able to adopt technology as a business. I've been in the IT business over 25 years, and it really was just a functional part of an organization. And now I think really to be able to respond to customer demands, it's not a functional part of the organization, it's actually a critical part of the business to be able to drive that forward. So working with the likes of Version 1, who have a wealth of experience in this space, you can't get much better than that really in terms of the experience they have to be able to migrate these customers and take them on that journey and push them down the innovative path. So I just want to say thank you very much to everyone at Version 1 for arranging this webinar. We'll be hanging around for questions if there are any, but Joao, back over to you. Thank you very much.
Thanks, Justin. So we'll start with some introductory concepts about application modernization. So what is application modernization and what does it mean? The definition that you can see on the screen comes from Gartner, and it is defined as a project that is designed to deliver new business value from existing aging applications by updating them with modern features and capabilities. And as you can see from that definition, application modernization is slightly different from a lot of IoT projects. It's not a replacement, it's not a technology refresh, it's a targeted use of technology in a specific area of an existing solution to deliver some level of modernization, but enables some kind of business value to be released. It's more of a targeted incremental approach, which minimizes risks to ongoing operations and activities of the business and is heavily driven by business cases. Now, when organizations are considering to do application modernization or not, there is usually some kind of compelling business-driven event or technology-driven event that triggers that process. It can be that their systems are built on top of legacy technologies and is becoming very costly to support and involve those aging systems, that there is a level of obsolescence in those systems, which typically does not enable them to use some of the new digital channels or other ways of working. They may also be at the end of their support lifecycle, or they may also went through a security assessment that raised a number of security concerns and vulnerabilities that can be exploited and cause data breaches, which in turn will impact the organization and their ability to be fully protected. There also may be that the business itself could be changing. There may be emergent business requirements to improve services, be more efficient, or tackle new market opportunities. Or there may be user experience issues and productivity concerns that need to be addressed to make the user get out of the system what they need. And even external business changes like mergers or acquisitions. All of those things would drive opportunities to consider either application modernization might be suitable or not. So typically, a business case that addresses application modernization needs to cover this sort of spectrum of triggers. And why would you modernize? You might have the triggers and opportunities, but what are the things that would make you modernize? Typically, what you're looking to do is to drive some kind of business benefit and bring business value with it. It can be an improvement of business efficiency, reduction in terms of cost, opening new market opportunities, or new levels of business agility. But what you absolutely have to be able to do is do it in a way that actually protects the business value, mainly keeping existing systems and production lines running. Application modernization is a way of doing that because it tends to focus on incremental delivery in a phased approach. And because you're only targeting parts of the application, you're automatically protecting a lot of the systems that are currently running and not risking a big bang delivery. And often you want to modernize also because there is a need to deliver things more quickly. Typically, digital approaches to markets require to deliver frequently and often, reducing time to market and providing innovation and something additional to the customers. And solutions should be modernized using modern technologies like mobile, IoT, AI, and so on, so that you can take advantage of those modern technologies. And more recently, we have seen that necessity is also a driver for application modernization, and that a crisis can reveal the danger of not modernizing quickly enough. The pressure of the current pandemic is exposing the risks of waiting too long to transform, get agile, and establish a path for modernizing the current systems. And unfortunately, in the current situation, it can be the defining factor to keep the business running. What are the patterns that are more used in modernization? And what is the modernization pattern? Is the process of decoupling business functionality from legacy applications and modernize it in a more cloud and digital first approach. Here I want to emphasize that application modernization is not just modernizing specific parts of the application, like moving an IT job to a more event-driven real-time approach. In an organization that has dozens or hundreds of applications running, completely modernizing one entire application is also application modernization. And what usually happens in monolith applications is because of how tightly coupled they are, most of the time it's not possible to just modernize one single functionality since it will have cascading effect So it will end up being a bigger project that lasts longer than expected. But at the same time, this is an opportunity to prepare for future opportunities and use the first modernization application as the groundwork and standard in terms of architecture and coding practices for the next applications further down the line. Now, the triangular pattern goes very well with application modernization. This particular pattern tells us to incrementally migrate a legacy system by gradually replacing specific pieces of functionality with new applications and services. Is a way to gradually create a new system around the edges of the old one, letting it grow slowly over time until the old system is strangled. This pattern reduces risks considerably compared to complete rewrites that have big cutover dates and increased pressure. With the strangler pattern, since it's a gradual approach and with frequent and shorter release cycles, it allows a better and more careful oversight and monitoring of the progress. It is a lengthy process, but it delivers valuable functionality and value to the business. Even if the business stops the process at some stage, the return on investment is greater than complete rewrites of the systems. It's also important not to forget that all we are doing is writing tomorrow's legacy code today. By building the applications with this pattern in mind, we are enabling them to be discontinued in the future in a more graceful way. So what are the approaches and how can you find the right approach for application modernization? Typically, when we are modernizing solutions, there are a number of different ways that you can do that. And you see on the screen here that we have listed some of those out. These are essentially the 6 R's on how you can approach a solution. You can either choose to rehost it and simply move it somewhere else. You can change the underlying architecture and environment that it sits on. You can refactor it, which is a light touch kind of application change, where you just make small scale changes, maybe separating different areas of the implementation. And these first two typically match well in a lift and shift sort of cloud migration or a migration to a different platform. And you have to make some targeted changes to achieve that. You could choose to re-architect the application where you modify significant elements of it and you significantly change underlying architecture or environment to enable you to do things later on. And there often tends to be a kind of stepping stone approach where you're looking at much bigger changes further down the line. You could choose to rebuild your application in a newer technology or a more native cloud technology, and you may well replace the underlying architecture or environment. The final two, replace and retire, are much more drastic, where you either replace your entire application or architecture, or you are simply retiring it because it no longer has value or is no longer needed. From an application modernization point of view, it's only the first 4 of those approaches that tend to be relevant. Because if you're replacing something or you are retiring it, there is really no opportunity to modernize it. The decision was made that there isn't a business value left and you're going to use a different approach. So application modernization is one of more of those approaches blended together. Usually it has a light level of touch to it, and usually you are restructuring or architecting in some way. You can rebuild it, but it tends to be less targeted in terms of the changes you're actually making. So how can we use Azure to modernize applications? And why Azure? Azure provides a vast range of platforms and tools that can be used, applied, and implemented to deliver successful application modernization. This doesn't mean the entire system needs to be moved to the cloud, but that you can move certain elements of the application to the cloud in a targeted manner. The usual roadmap for application modernization always starts with a hybrid solution, with a view to completely move to the cloud at a later stage. And Azure, as a platform and cloud provider, gives all the digital innovation and tools that are needed to perform successful application modernization, especially in terms of reliability and security. It is a powerful and flexible foundation for existing and new applications. It is highly secure for infrastructure and applications, built-in security services and unique intelligence to protect your workloads against threats, has fully managed capabilities like built-in auto-scaling, CI/CDs, load balancing and failover. Also has superior tooling for monitoring, telemetry and debugging, as well as integration with Visual Studio, GitHub, Azure DevOps, Bitbucket, and many others. And to finalize, it brings cost savings due to the pay only for IT use model that reduce significantly hardware costs. And some, if not most organizations, already have an IT ecosystem based on Microsoft technologies. So a transition to Azure becomes an obvious choice, especially considering that Microsoft offers the tools I previously mentioned and more that can help organizations assess their IT infrastructure and plan for a cloud migration. It's not the case anymore that if an organization is using .NET, they should only go to Azure. But it's not the case that Azure supports several technology stacks, so it doesn't really matter what you use. You could just go with Azure as a cloud provider. So how do we choose the appropriate services for application modernization? As usual, the answer is it depends. There is one thing in application modernization that should be a focus point, which is to focus on applications and data and less on servers, making the choice only between platform as a service or software as a service, so you can get the most benefits from the cloud and focus in creating value and less on building infrastructure and benefits like auto scaling, security, and because it's an evolving platform, you'll get new features available as soon as they're added. And we've seen that current trends tells us to start using some types of architectural patterns when thinking about the cloud and cloud native. Some of them being containers, microservices, event-driven, and serverless. I'll start with containers since nowadays almost everything is moving into containers. And it's a technology that fits very well with application modernization since it allows organizations to move existing applications to the clouds as containers, since containers can be deployed anywhere. It requires like a small initial effort, but you gain a lot later on in deployments. And for example, microservices tells us to build small independent services that encapsulate a specific business capability. And typically, those services are packaged in containers. And for that, we can use services like Azure Kubernetes Service and Service Fabric, which are specifically built for microservices architectures. AKS being a container orchestrator that is being used widely in several well-known organizations and service providers, and Service Fabric, which is Microsoft proprietary distributed systems platform for microservices and is used to power many Microsoft services like Azure SQL, Cosmos DB, and Power BI, for example. Also, it was now announced that AKS supports Windows containers. So if your application depends on Windows operating systems, you can now lift and shift it to a container platform on Azure. Container instances is an alternative way to deploy containerized services in web applications that don't really need container orchestration. And for app services, you can deploy containers to them, but you don't even need that at all if you don't want to. You can just publish the output files from your applications to an app service, and it just runs. Event-driven and service architectures complement each other quite well, where some form of cloud event triggers a backend process that can be ephemeral and doesn't require traditional server components. For that, we have options like event grids, Azure Functions, and Logic Apps, where event grids is the service that triggers the cloud event, where functions and Logic Apps act as the backend service. There are differences between the two. Functions is a code first and can be run locally, where Logic Apps is designed first and runs only on the cloud. But both have a wide range of built-in triggers and actions that simplify development and deployment considerably. Note here that serverless typically refers to backend as a service, but in the Azure landscape, all platform as a service services are serverless. API management cognitive services are good examples where you can bring a lot of functionality and benefits to the business in a modernization journey, and you can completely avoid infrastructure management. In the application modernization cases that impact the data store, selecting the right one for your requirements is a key design decision. Modernizing data stores, it's not an easy feat. It always needs a lot of consideration. But in most common cases, just the fact of doing a lift and shift from an on-premise database to a cloud VM, or better yet, a platform as a service offering, gives benefits, not just because of the cloud capabilities, but also in terms of operational support and costs. Another thing to consider here is the fact that now, since our data is in the cloud, we have the possibility of applying data intelligence to that data and start extracting analytics and insights that can give the business the possibility to adapt to trends. In Azure, we have the most common storage data models. So for most application modernization scenarios, the data store that we require should be there available for us to use. If we have to go with relational databases, then we have Azure SQL, Postgres, MySQL, and MariaDB as available options. If the decision is to go with a NoSQL store, then the first choice is usually Cosmos DB. And Cosmos DB is special in a way that it has multimodal support. It's not just NoSQL, but key value pairs and graph databases as well. And it's highly flexible for those. And for those different models, it has specific APIs that you can use. An example is if your organization has an on-premise MongoDB database, you can migrate to Cosmos DB and use the same query syntax that you're using before. We have Azure Search for NoSQL search stores, where these databases have the ability to store and index information very quickly. And this is ideal for applications that have a high volume of search requests and need fast response times. In the cases where there is a large amount of data in real time, IoT for example, time series is a NoSQL store that is used to collect that data from a large number of sources and organize them by time. And it's ideal for displaying in real time the data coming in from the stream by using a live graph, for example. On the analytics side, we have Data Warehouse and Data Lake, which are optimized for massively parallel solutions for ingesting, storing, and analyzing data. Stream Analytics is not really data store, but it needs to be represented here because it's something commonly used by big data for complex rule processing. And if what you need is just a large hash table, then key value stores are a perfect fit. Something like Azure Tables, Azure Redis Cache, or Cosmos DB. If there's also a need to store files, then we have Azure Blob as an object store where you can put images, files, videos, audios, like whatever type of file we need. Now, we've seen in the past slides that a trigger for application modernization can result from security concerns or security assessments. So let's look at how Azure can help, not just with the security aspect, but with others as well. These types of services are ones that should be considered and applied to any type of new application or application modernization opportunities. If we're looking at security and authentication of our applications and APIs, then we're looking at Azure AD or Azure BTC if we're dealing with external users to our application. If, for example, if our application needs the user to register and create an account. Another important aspect is, since most applications use some sort of connection details to access services, that normally includes secrets like passwords or keys. For that, we use Azure Key Vault for secure secrets management. And another element that should be used when building Azure applications is Azure Managed Identity. This is a feature of Azure Active Directory that provides Azure services with an automatically managed identity. And this identity is used to authenticate to any service that supports Azure AD authentication, including Key Vault. And this without having to deploy the application with any type of credentials. And this works not just for applications running in Azure, but also during development, meaning developers can connect to the services without having the credentials stored in their local machines. For resiliency, we're looking at a combination of application design and Azure load balancing services. These services are the components to use to build highly available applications. Services like Traffic Manager, Front Door, and Application Gateway. They offer different capabilities, but what I want to highlight here is the difference between what is a global and a regional load balancing service. A global one distributes traffic across regional backends, like two different Azure regions, like North Europe and West Europe, while a regional one distributes traffic within virtual networks in a specific region. So Front Door and Traffic Manager work globally, while Application Gateway is a regional one. Now, using these services is not enough to make an application fully resilient. For that, the application must be designed in a way that is able to recover from failures and continue to function with minimal downtime and data loss by applying techniques like retries, timeouts, or circuit breaker. On the scalability side, in Azure, most platform as a service services and even infrastructure as a service services offer scaling capabilities. And this simplifies significantly the ability of a system to handle increased load. We have app services that can be scaled up, that can be scaled out, and have auto scaling built in. If you're using virtual machines, there is virtual machine scale sets. AKS and Service Fabric also have scaling capabilities. And serverless services like logic apps or functions scale automatically. So for them, there is no need to configure like the number of instances or auto-scaling rules. Azure also offers several tools to manage monitoring. Application Insights is a service that can be plugged in to any type of application, either web or, for example, a Windows service. And it has an SDK that can be used to extend the login capability of the applications. Most, if not all, of the login and monitoring services in Azure can be accessed in a central location in an Azure portal through Azure Monitor, which collects, analyzes, and acts on telemetry from your cloud environments. And tools like Log Analytics allow you to drill into your monitoring data for troubleshooting and deep diagnostics. And for costs, in the Azure portal, we have Azure Cost Management and Billing, which gives us billing and administrative tasks. We can manage billing access to costs, and we can monitor and control Azure spending and optimize Azure resource use. The last thing I want to mention on this slide is that when you're modernizing applications on Azure, there are design principles that need to be followed to make our applications more secure, scalable, resilient, and manageable. And as we saw, using Azure simplifies that process a lot. It gives us all the tools and services that we need, and after we assembled all the building blocks, and we end up with a really modern application that meets the business requirements and can bring real value. One thing that fits well with application modernization is DevOps and Agile, especially because we are aiming to modernize with incremental and more frequent release cycles. It might be hard to get organizations to change their mindsets from waterfall to this approach, but if that change is successful, it comes with great benefits. And application modernization is also improvement of the processes and toolsets that are in use for continuous integration and deployment. Or if they don't exist at all, just the fact of implementing them is valuable. Organizations can benefit simply from the fact of automating the release process, removing lengthy, repeated, and inefficient manual releases that usually carry some degree of risk, to a more automated process that can literally take minutes, meaning that developers and operation teams can spend more in tasks that bring value to the business instead of spending full days in deployments. And if you're using tools like Azure DevOps and Visual Studio with the Azure Cloud, the setup of this process is even easier. It's very straightforward to create new applications or publish existing ones to Azure and connect it all together in an end-to-end process with these tools, since they integrate very well. With Visual Studio, for example, developers can build, run, and deploy cloud-native applications on their workstations in a matter of minutes. And it's just as simple as creating a new project in Visual Studio and then right-click and publish to an Azure App Service. And with Azure DevOps, it has built-in tasks that integrate with Azure. So you can create pipelines to build and release to every service available. And this doesn't mean that teams have to completely migrate their tool sets to Azure DevOps. The platform does make it exponentially easier to work with Azure, but teams can adapt their processes and tools around it since it's very modular. If you want, you can just use Azure pipelines for CI/CD, and you have your source codes in GitHub or Bitbucket, or the other way around, where the code is in Azure repos, and you have a Jenkins server for CI/CD. And integration with several external systems, it's also available. Teams and Slack for real-time notifications, and Solar Cloud for static code analysis are just some examples. Okay, so let's move on to the scenarios. We'll start with modernizing user experience. In this first example, let's picture we're working on a legacy enterprise system like SharePoint 2010. One of the business applications was built under it, so all the UI is SharePoint based, and the main reason for it was to use the SharePoint document library, but the application as well also uses other on-premise services. So what sort of challenges are we facing here? We do have a legacy UI, everything is still on-premise, and it's reaching end-of-life support for the underlying infrastructure. And what are the application modernization opportunities that we have here? The obvious one is platform obsolescence, where we have a legacy platform that is costly to support and evolve and lacks modern features and capabilities compared to the public clouds. So after going through the modernization process, how would this look like in the Azure cloud? And how did we apply the application modernization principles? By using two of the R's that we've seen before, rebuild and rehost. On rehost, we're doing a lift and shift of critical pieces of the application to minimize the risk as much as possible. More specifically, the underlying database and some backend services. On the database, we're moving an on-premise SQL Server VM to an Azure SQL Server VM. Straight away, we can make use of the built-in Azure capabilities for monitoring, resilience, and scalability, and have a view of the virtual machine metrics and logs in the Azure portal by using Azure Monitor. The backend services follow the similar approach, but by the means of containerization, with no changes to the core business logic, just to the underlying platform, and in this case, AKS. Again, as I mentioned before, AKS now supports Windows container workloads. So if these applications were heavily dependent on Windows, we could have just lifted and shifted them with no to a managed Kubernetes cluster. Rebuild was applied in two components: the UI and a specific service that was only uploading files to a document store, in this case SharePoint. The service was built as a .NET Web API, and after a close analysis, it was easy to spot that this could run as an isolated process, like a single method. And for this, Azure Functions was ideal. So we were able to move that piece of functionality to a serverless function, put some monitoring on top of it, and not have to worry about infrastructure at all. And again, all of this was done quite easily with Visual Studio or Visual Studio Code. The UI component had to be rewritten since the users were having some issues working with it, and it was just not suitable anymore for their needs. And here I just want to emphasize that rewriting should not just be a copy and paste of the code, but an opportunity to challenge and improve the process and remove constraints built over time and decide if the technology is really the best tool for the job. Here the decision was to use a more modern framework like React, Angular, or any other to give the users a better experience. And since the UI was deployed to an Azure App Service, it really doesn't matter what you use. You can deploy PHP, Java, Python, etc., and it just runs. So what kind of benefits could we achieve from this? The main one is the improvement of the UX. The users now have a rich UI and there's less clicks involved, and they're more productive, which brings business value. We have the cloud benefits like better monitoring, performance, and security, as well as reduced costs on supports and maintenance. Some of the on-premise service could be retired completely or repurposed. And for future modernization opportunities, it will be easier now since the cloud platform is prepared for that incremental migration. So let's move on to the next scenario then. So let's look at modernizing integration capabilities. In this scenario, we have a legacy Windows desktop application that is just not suitable anymore for the business needs. There is a high volume of support tickets about the application constantly crashing, and they're normally in relation to the user's machines or operating systems. And the application is also very tightly coupled with on-premise hosted services. And the application is mostly for inputting form data. So again, what sort of challenges are we facing here? It's a legacy Windows application. There's tight coupling with on-premise, and we are not able to move to digital platforms. And what are the application modernization opportunities that we have here. For this case, we actually have emergent requirements. So the application needs to meet, let's say, legislative or regulatory commitments, and in user experience, because now the application needs to be available in different devices like tablets and mobile phones. And after going to the modernization process, how would this look on the Azure clouds, and how do they apply the modernization principles? Here, we could use rebuild, refactor, and re-architect. We'll be re-architecting by making a significant change to the underlying architecture, by implementing a publisher-subscriber pattern, as well as asynchronous programming to the application. So this type of application doesn't require an immediate response to the user. So we can fire all the messages that we need to a messaging platform like Service Bus. Let them be processed by the backend and have the results returned to the user at a later stage with minimal interruption to their work. The backend processing was not complex, so logic apps was the obvious choice. The flow is a simple, we need to read a message from Service Bus, we inspect the message properties, and then we send the message to an on-premise API. And since logic apps have all the triggers and actions required to do this, and a lot more, it can be built in a matter of minutes. The publisher subscriber pattern was built on top of Service Bus. And one of the features that Service Bus gives us is topics, which is something like the entry point where the application can send the message to. And subscriptions, which are just normal message queues, can apply filters to the messages that arrive in that topic. This suits us because some of the messages might need to be processed by different logic apps and sent to different on-premise APIs. The rebuild is very similar to the previous example and brings the same benefits. The main difference here is, since this application will be used by user external to the application, the authentication and external user store will be Azure B2C, where the users can register, log in, and perform self-service tasks like password resets without minimal operational support. So what benefits did we achieve here? Similar as before is the business benefit from improving user productivity, and we can now reach different device types. There's reduced operational costs, and the application is now resilient. The systems could be run in parallel for an easy transition, and now new features are much quicker to release. And any other integrations can now avail of the in-place Service Bus, allowing for extensibility for other business requirements or channels. There is an alternative way that this could have been built, which is something that Azure has called hybrid connections. And that's part of the app services. It's both a service and a feature that creates a secure relay between the clouds and the on-premise network. The advantage of it is it doesn't need firewall ports open and all communications are outbound. And event grids is something that could be also used in an integration scenario. But it's more when you need high throughput, velocity, and in real-time processing of events. So let's imagine if you upload thousands of files to a blob storage, that can then you can then have event grid trigger an Azure function to each one of them, and all those functions will run immediately and in parallel. And to finish up, Service Plus was used here because since it's a PaaS service, so there was like no configuration needed or close to none. It's very cheap. We get millions of free messages compared to servers running 24/7. It is an enterprise-grade messaging platform. So let's move on to the last scenario. In this last scenario, we'll look at modernizing analytics and reporting. In this scenario, we have a company that has multiple offices around the country. And in each of the offices, the exact same version of the application is deployed. And that application records data specific to that part of the country and has exactly the same data schema. Every week, a report needs to be presented to the head office. So in the current process, each office exports data from the on-premise database to the Excel spreadsheet, sends it to the main office to be processed further, and only then it will go to the CEO. What sort of challenges are we facing here? The process is very manual, the destination data is not very reliable, and we have a delay of a couple of days. What are the application modernization opportunities that we have here? So we have repeated and inefficient interactions, and it's a system which is very high on the company's business register, and it is considered mission critical. So after going through the modernization process, how would this look like in the Azure clouds, and how did we apply the application modernization principles? So we did a rebuild on the report to a Power BI report. Excel was just not the adequate reporting solution for the business requirements. We used refactor on the way the application is exporting data. Currently, or it was previously using stored procedures to generate the Excel files. And those stored procedures was changed to, instead of creating those files, they can now be used for queries coming from external services. And in this case, we're using Azure Data Factory to get the data from all the sources that we need. And it can be any type, not just SQL Server. It can be Oracle, SAP, or others. The data is then processed by Data Factory pipeline and stored in some type of data storage. Again, that can be Azure SQL, Azure SQL Data Warehouse, Cosmos DB, Data Lake, etc. It's just to demonstrate that Azure Data Factory can transform, model the data, and store it not just in relational databases, but non-relational as well. From then on, Power BI comes into the mix and uses the data sources to produce highly visual and interactive reports and dashboards. So what benefits did we achieve here? We now have a centralized reporting solution. There is no more manual processes. And we have improved insights to the data, since now it will be real-time data that can be accessed anywhere. Now, to finish up this slide, if organizations start unlocking data from their existing applications and publish it to a data lake as soon as they can, they will be able to do intelligent data science, machine learning, and artificial intelligence projects in the future, since all that historical data is there available to be used. And that means they can make their applications richer, offer new features and services, and based on these predictions and insights, can give them advantage when compared to the competition. That's everything for today. Thank you for joining. If you have any questions, please get in touch.